Okay. Good afternoon, everybody. Thanks for being here. I know Andre's talk I would have loved to see downstairs. But my name is Neil Power, and I'm here to talk about kickstarting Kotlin culture, the journey from Java to Kotlin. So, my name is Neil Power. I'm a software developer at Hootsuite. I was on the Android team for the better part of 2 years, from early in 2016 until just recently. And I'm now working on the developer products team, building out Hootsuite's developer platform. And currently, I'm experimenting with Kotlin backend services. Hope to have a talk maybe next KotlinConf. So, this talk is about our experience adopting Kotlin at Hootsuite. And based on the lessons we learned, we wanted to share our story so others can accelerate their adoption. We are growing Kotlin culture at Hootsuite, and we're facilitating that growth in the community at large. The core of our story is about empowering other individuals and companies to learn from our experiences to turn to the future of Kotlin in their organization. So let's start with a little background information. Hootsuite is a social media management platform. We integrate and aggregate social media products. We have a web-based product you can see, as well as a companion mobile product. It shares some of the same functionality with the main app, but it also has its own features. And for any Android developers in the room, I could only get professional iOS photos for my slides, so I had to make my own for Android. But hello, KotlinConf. So why am I here, other than that I love Kotlin? Well, it's largely thanks to Hootsuite's developer culture. We have a culture of experimentation. We were early adopters of Scala for backend services, and we put Kotlin into production with hundreds of thousands of monthly active users shortly after the release of 1.0. And we learned a lot of lessons in that process, which I would love to share. I want to share those lessons because I'm a real believer in working out loud, a term that was taught to me on my very first day at Hootsuite by a great mentor, Noel Pullen. And I see working out loud as a drive to work passionately, to know that what you're doing is valuable to someone, and to strive to share what you've been working on with those around you. It could be sharing with your team, it could be sharing with your company, it could be writing a blog post, or presenting at a conference like this one. And also, for the background, a little bit about how we work. At Hootsuite, we have a core mobile team, the team that I was on, and it's focused on library-driven development, which is something that I'll explain shortly. We slice our app into verticals, and these verticals are owned by different teams across the company. As a social media company, one of these verticals is planning and creating content to send to social networks. Another is to engage with content in your social feeds. So as I said, these will be different teams than the core team, working on their own features. So the graphs that I'm showing you here are real snapshots of our internal Android libraries at different points in time. They're dependency graphs, with each node being a single repository to which one or more team contributes. At the top is our main app, which we ship to customers. All the other libraries are composed into it. And finally, in the background, when we first considered Kotlin, these were some of the risks that we identified. First, and most importantly, it was an unofficial Android language. As developers, we were eager to try to work through any bugs, but we know that we have a responsibility to our customers to create and to maintain a stable app. Using an unofficial language could make that difficult. There was also a risk of learning a new language at all. It takes time to become proficient in a new language, and not necessarily everyone will be on board. There's also a risk of increased build times. Bringing in new libraries and plugins, it always has the potential to slow builds. We also have a continuous integration pipeline in our mobile products at Hootsuite, and we had to consider if it was going to cause problems there. There was a risk of IDE tooling support. Maybe not everything would work nicely together in Android Studio. And finally, we considered the effect on hiring. Would we be able to attract talent if we were using such a new and untested language? So now let's talk about our first line of Kotlin. But let's start with our first exposure. In February of 2016, a Scala and Android developer at Hootsuite, who had participated in the Scala experiment at Hootsuite, took notice of Kotlin. He suggested trying it at Hootsuite. He was always an early adopter. And he shared Jake Warden's now famous Using Project Kotlin for Android proposal with the team. Fast forward to March, not everyone yet convinced. The team looked at more evidence, including Talking Kotlin with Hadi Hariri on the Fragmented podcast. And then core Android manager Simon C. created a sample app in Kotlin just to start playing with it. It was in April, early April, that our director, Paul Cowles, encouraged us to keep exploring, testing out this new language. Bolstered by that, Simon converted our first Pojo into Kotlin, a Poco, I guess. And here's the first commit, April 6th, 2016, dawn of the Kotlin into the core library, a single conversion of a Java to a Kotlin data class. And after testing that this worked in the main app, we shipped the app, and we had officially Kotlin in production. And that's where it begins, just a single class. So let's start diving in. After that first commit, the team realized that they really have to start learning Kotlin in earnest. And it's at this point that I joined the team in April of 2016. So we started with the Kotlin cones, with the great exercises to get started with Kotlin. Each developer took the cones home, solved them, then we brought them in. We shared our solutions with the team, shared the challenges that we saw. And at first, we were writing Java with Kotlin Syntax. Here you can see an Android onCreate function. Looks a little like you would in Java, null checks, find view by IDs. After a little while, we were writing small amounts of production Kotlin code. We were getting a little more comfortable. We read the docs, we experimented with features, and we shared our knowledge on the team informally. Started to write a little better Kotlin. Maybe we used synthetic imports through the Kotlin Android extensions. No more find view by IDs. Maybe a let block instead of a null check. And for us, it was love at first compile. And there's lots of features to love in Kotlin, as I'm sure everyone here is aware. Data classes, reducing 100 lines of Java to 10 lines of Kotlin. Fantastic. Null safety with nullable types. Later, when we ship more and more Kotlin, we'd see a dramatic decrease in null pointer exceptions. Kotlin, of course, has a rich collections API. You're able to map to filter collections, among many, many other operations. And also first-class functions. Passing functions directly to functions opened up a whole new world of possibilities for us. And it progressed over the months into idiomatic Kotlin. For example, we were zipping infinite sequences together to generate Facebook tags. We were writing inline functions with Reified generics to get lists of notifications. So how did we start writing bigger pieces of our app in Kotlin? We started with Kotlin libraries. We knew that converting data classes was not going to be enough to accelerate the adoption of Kotlin at Hootsuite. We decided to write a new feature in Kotlin, and it should have enough technical complexity to test Kotlin and really see if it's a good fit, and it should be decoupled from the main code base, so if we do need to go back, it's easier. So we decided to try Kotlin on our incoming compose feedback feature. And this feature showed the user a status of their messages posted to various social networks. So it was technically complex. There was a job queue to handle all the responses from the different networks. There was persistence in the DB, API calls, custom views, and the feature was written in its own library, and it was over 90% Kotlin. We learned a lot writing this feature. But we knew that we had to go bigger. We knew we had to go toward our first 100% Kotlin library. And after the success of the compose feedback feature and no major Kotlin issues, we selected Query Builder for our first fully Kotlin library. Query Builder is a visual search builder for Twitter. It started at 90% Kotlin, but after overcoming some challenges, we were able to bring that to 100%. One challenge was early issues with Dagger and capped and generated code, and we couldn't quite get it to work. Sadly, we had to revert to Java for a little while. But we resolved the issues, and after cap was updated, and we were able to bring it all back to 100% Kotlin. So we also had some other challenges with the Antler-generated code. We were using Antler to parse our search queries. Antler generates a lot of code. And we solved that by extracting the code into AWS Lambda function so that iOS could use the same functionality for their feature. However, then we had issues communicating with the AWS Lambda with the Java SDK. So finally, we used API Gateway in front of our AWS Lambda function. And all we needed to do was write simple retrofit API endpoints to communicate between the Android app and our Lambda function. So the Query Builder was really a great isolated experiment. It was away from the main app. It had a lower risk for customers. And extracting it all into a library was great for mitigating our uncertainty with Kotlin. We could test in the sample app, and it was building, it was working, it was great. We had a fast build cycle, and we were able to test an integration test in isolation. And so with these features, we saw Kotlin Love from the team. We work in sprints with retrospectives where we answer what's working and what's not working, as I'm sure many of you do. And for Kotlin, it was almost always on the working side. And recall now that these retros, these features, were just for the core Android team with core Android features. All the other satellite Android teams were still fully Java teams. So we wanted to start to spread that love for our love of Kotlin to the other teams in the company. We wanted to start growing a Kotlin culture at Hootsuite. So the cones were a really great start to accelerate our learning. And as I mentioned, this started on the core team, and the other teams are using Java. So how could we grow it at the other teams? We needed to start to develop Kotlin standards, because maybe other directors weren't as all in on an experiment. We had to elevate Kotlin knowledge on the team to know that we were writing good, testable, clean code. And we had to share lessons learned from the community to the other teams so they wouldn't make the same mistakes we did. And I want to just introduce the concept of a guild from that very Noel Pullen. Collective action is a wonderful thing. People getting together to have a conversation about the things they care about with the aim to do something positive for themselves and their community. How can that collective action happen inside your organization? At Hootsuite, the answer is guilds. So what is our solution to evangelizing Kotlin at Hootsuite? It's the Kotlin Guild, later the Kotlin Book Club, and also the Vancouver Kotlin Meetup group to spread it outside Hootsuite. But let's look at the Kotlin Guild as what that was. We founded the Kotlin Guild in July of 2016. We used Workplace. It was a great place to communicate all our ideas, documents, etc. And its purpose was to allow people who are interested in Kotlin to share their best practices, to discuss interesting articles and videos, and to help create a unified style for Kotlin at Hootsuite. And the format is bi-weekly meetings. They're opt-in. They have a shared agenda where everybody's expected to contribute, even just a curiosity. And the Guild is company-wide. Anyone can come to the meetings. You didn't need to be an Android developer. You could be on any team. And that goes for all the guilds at Hootsuite. So here's an early agenda from just session 3. I was reviewing the cones with the new Kotlin developers that we were trying to train up. Our co-op Noah was talking about how we use delegated properties in Query Builder. And our co-op Dennis was talking about how Kotlin language proposals go through Keep. And the Guild, after KotlinConf was announced this year, it was a brainstorming session on what talks we could submit. It was actually there that I first suggested telling this story to work it out loud. We also held a retro for our Kotlin 1.1 event to discuss how we could bring more people in Vancouver into that Kotlin development community. So it was also at that Guild we started seeing interesting language features. Sequences? When we first saw sequences through the Guild, it was a first for the whole team, a new feature. And if you're not familiar with sequences, I'll just give a quick overview. Here we see a generated sequence from a list of 2 elements. We then map over that sequence, printing map at each iteration, calculating the square. Then we filter the subsequent list, printing filter at each iteration, and just checking if it's even. Then we convert that back to a list. If you're not familiar with sequences, you might expect, as we did, the output to be map, map, filter, filter. But instead, we saw map, filter, map, filter. So this is because sequences are lazy. If you put a take 1 at the end here, you'll actually never even generate the second map and the second filter. So this was a feature that made us realize, wow, we have a lot of Kotlin to learn. And so we decided to look into more structured learning. So the Guild would continue. It was a great way to chat informally, but we wanted additional time to learn Kotlin in a more structured way. We planned to use reference material with hour-long meetings every 2 weeks. We had personal study between meetings, so you could brush up on the material, bring your questions to the book club. So why did we want to do this? Well, we wanted to increase our developers' engagement with Kotlin. We wanted everybody to be as excited as we were. We wanted to accelerate learning by learning together and sharing pitfalls, sharing excitement. And we wanted to find the next sequences, the feature that nobody on the team yet knew about. So we chose for our first Kotlin Book Club book, Kotlin in Action, written by 2 members of the JetBrains team. We read 1 chapter a session, having roundtable discussions with each person leading a section they read. Then, people created exercise based on the book material to review with the rest of the book club. So in Kotlin in Action, we learned the 4 core principles of Kotlin. First, that it is pragmatic. Kotlin is a practical language designed to solve real-world problems. We learned that it's concise. The syntax clearly expresses the intent of the code you read. It's safe. The language design prevents certain types of errors in the program. And finally, Kotlin values interoperability. Regardless of the kinds of APIs, you can work with them from Kotlin. And so this principle ended up being core to our Kotlin adoption at Hootsuite. Like I mentioned earlier, it starts with a single data class or a single line of Kotlin. And it grows from there. So we also had some interesting discussions, such as when we were reviewing the type system, where we realized nothing is everything and everything is anything. It was an interesting realization. And we started to build standards for Kotlin at Hootsuite. When should we use an extension function? Well, we learned early it's not simply replacing a variable being passed to a function. When should we be creating or overloading operators? Infix functions are interesting, but not always appropriate. And when should we be using the aforementioned sequences? Well, there's overhead converting between lists and sequences, so it makes the use of lists are frequently a better choice. And how should we use all these new interesting block functions, let, with, run, apply, also? Well, we created this chart, which I've actually subsequently seen in at least 1 blog post, so we can claim to be at least independent inventors, of the symmetry between apply, run, let, and also. And in addition to just this diagram, we expanded on when you should use each feature in our style guide. So let's look again at how we develop Kotlin at how we develop Android at Hootsuite. We use what I said was library-driven development. Looking back to 2015, our Android app was a giant Java monolith. I'm sure everyone's in this room might have encountered it if they're an Android developer. It's slow to build, hard to distribute code ownership across teams. We wanted to move faster. And to do so, we started working on decomposition. That is, the decomposition of our Android app into libraries. In late 2015, we started to consider the problem that we had. We envisioned composable libraries that are each their own repository. We basically had one giant app at this point. So through 2015 and 2016, we started putting features into their own libraries. And it was April of 2016 that we started Kotlin, and soon after that, we started writing all Kotlin libraries. Our main app was getting smaller. Now, in 2017, we have many libraries, most of which are entirely Kotlin. Different teams own and maintain each library, and the libraries are composed together to build the app that we ship to our customers. This decomposition meant new features were in their own libraries, but also we started to refactor our monolith, Hootroid, into reusable components. So why did we do this? 1, it led to a better architecture. We found that when we had to separate features into their own libraries, you really had to consider the interfaces between the features and the main app. It was harder to simply cheat. It also allowed us to introduce Kotlin in a steady but controlled manner. And writing new features in Kotlin, but also refactoring old code into new Kotlin libraries. So here again is a dependency graph of our internal libraries showing the dependent links between them. At the top is our Android monolith, Hootroid, written almost entirely in Java and containing, honestly, tens of thousands of lines of legacy code that we're slowly chipping away at. Below those are our feature libraries that I mentioned earlier, those vertical slices. Most are in Kotlin now, with 1 still mainly in Java. Below that, we have libraries and tools, and labeling the nodes on the rest of the graph, you can see many are predominantly Kotlin. The bottom of the graph here, some of these Java libraries, are unfortunate side effects of that legacy code. They're forks of Volley, a networking library, that we are working to get rid of, but still have been unable to. So some of the benefits of this decomposition, as I mentioned, it's easy to make new libraries Kotlin only. It's easy to delegate ownership to different teams. And there are much faster builds when using pre-compiled modules. However, there are some drawbacks as well. There's increased overhead for project configuration. Now, fortunately, we've been able to mitigate that somewhat with library templates and scripts to generate libraries. But the main drawback is that you need to keep your libraries versioned and in sync, much like with external Gradle dependencies. So let's briefly talk about the tools that we created to automate this overhead away. So if library-driven development creates developmental overhead, what can we do? Who wants to manually bump versions of internal libraries? At Hootsuite, we use tools Atlas and Peon to mitigate this overhead. Atlas is a command-line Ruby application which determines and visualizes project dependencies. It was originally written by myself and an iOS developer, Ben Hergert. We use it to create dependency graphs for iOS, Android, and our Scala projects. All the graphs that I've shown you throughout this slide were generated by Atlas. It can visualize projects to help people understand their projects better. So below is our current graph just before I left to come to this conference. You can see a number of different colors. So visually, Atlas will show out-of-date dependencies as amber ovals, as well as mismatched dependencies with red lines. And this helps developers diagnose quickly where the problems lie. So what do we use Atlas for? We graph, build, and sort for Peon, which I'll explain in a second. Onboarding new Android developers has been a great use of Atlas because it allows people to really understand our own internal ecosystem quite quickly. And Atlas graphs are shown in status boards around the office to see, is something getting too red? Maybe we need to increment a library. It helps us diagnose bugs in development. So Peon is another command-line Ruby application written by myself and Simon C. And it takes input the graph structure that Atlas outputs, as well as the dependency updates that you wish to apply. Peon topologically sorts the graph and creates ordered pull requests with the given changes. So if I have a networking core library version 1.2 and I want to bump it to 1.3, I tell Peon that, it looks at all the dependencies, it topologically sorts the graph, and then it creates exactly the right number of pull requests in order. So the output of Peon is a Slack message operating on the topologically sorted graph that messages the pull requests. Now, if you merge them in this order, all the dependencies, the transient dependencies, will be fixed along the way because Peon predicts which versions will be where. And you can see here from an Atlas graph from a run before and after Peon. After a single set of pull requests, the graph is nearly problem-free. Peon can also be used to bump versions of Kotlin or Gradle across our entire graph, and it propagates the changes all the way up to the main app. When we bumped from Kotlin 1.0 to 1.1, it was a simple 18 pull requests, approve them and merge them, and you're done. So one of the reasons that I bring up these tools is because I'm currently rewriting them in Kotlin with the intent to open source them. So if you're interested in these tools or you think they could apply to your development, please come talk to me because I'd love to get input. So beyond Hootsuite, how have we gotten the community involved? Well, we wanted to grow the Kotlin culture beyond Hootsuite. We had all our Android teams now working in Kotlin nearly 100% of the time. And it started with the Kotlin 1.1 event. It was the only official event in Canada, and we founded the Vancouver Kotlin Meetup group for the event. It helped us engage with JetBrains. It helped lead us for me to be here today. I was very excited to submit the event. I founded, like I said, the Vancouver Meetup group just for the occasion. Here are some of the teams getting ready for the event. Got an Owly on Simon's head there. So the event itself went really well. We had talks by Hootsuite developers, unfortunately no external developers. It was our first meetup in Vancouver, a chance to engage with the Kotlin community there. Since then, we've had several meetups. Our goal is to grow Kotlin in Vancouver. If you saw me, I had this shirt on yesterday from our Kotlin night, sponsored by JetBrains. They were nice enough to send us some shirts for the speakers. So this was the first event that we actually had participation from companies outside Hootsuite, themselves interested in Kotlin or currently using Kotlin in production. And there's some people here from the user group today even, because JetBrains gave us some free tickets, so thank you, JetBrains, for that. But recently, we've started to host Kotlin Beginners Night. When we did a poll, a straw poll of our participants, we found that more than half of them had actually never written a line of Kotlin. So they had started to ask, hey, could you kind of give us some talks to get me up to speed? Because a lot of what we had been talking about presumed a certain knowledge of Kotlin. So we held a night of introductory talks with workshops on language features afterward. So this event was a great success, and we plan to hold more. I think it's a great way to get more people pulled into the Kotlin community. You could see a shot here of Simon just workshopping, I forget the language feature, but it was a nice kind of small group. They got their questions answered, I heard. And finally, let me look at the history of Kotlin and Java at Hootsuite. So first, I wanted to look at per sprint contributions. Here, we have a graph of Kotlin contributions in red and Java in blue, per sprint since April 2015 when we introduced Kotlin. I used the tool CLOC to count the lines of code. Now, this tool separates code from blank lines from comments, and I separated it from tests and sample apps. So what you're seeing is just purely lines of code, production code. So if the date might be hard to read, but you can see some of our milestones aligned to this graph. Our first Kotlin feature in June of 2016, here, you could see a spike of lines of Kotlin written in those sprints. At the end of the year, we spent a lot of time refactoring some of that monolith into Kotlin from Java. So you see dips in Java when we actually removed it from our code base. And you could see where we went all in after Kotlin 1.1 was released, removing huge swaths of Java, and even more after Kotlin Official when other teams really bought into. So how about cumulative lines of code? If you see the same graph, Kotlin in red, Java in blue, but now we're looking at the net change since we introduced Kotlin in April of 2016. So you see here we're at 0, 0. You could see that when we started to write more Kotlin code after the Guild was founded here, though I'm not saying correlation implies causation, you could see the drop after we went all in on Kotlin with 1.1, where we were starting to really take a lot of Java out of our code base. You could see where we started the book club. It continues to rise. And after Kotlin was made official, like I said, other teams really started to buy in. So the net result after a year and 6 months is that we've written 42,000 lines of Kotlin, and we've removed 14,000 lines of Java. And remember, of course, that Kotlin is significantly more expressive. One line of Kotlin is more than one line of Java. So if we look instead at the overall lines of code in the code base, you can see a graph of our code base in its entirety, main app, and the libraries. Again, Java in blue and Kotlin in red, but now we're showing that whole code base. Still no tests or sample apps, though. So we started in April of 2016, with 110,000 lines of Java. Now, at the end of last month, we've grown to 42,000 lines of Kotlin, and actually we've removed, so we're just under 100,000 lines of Java now. And we have a huge legacy problem. Like I said, there's a significant rectangle below. But if we look just at our main app, you're going to see the difference between library adoption and main app adoption. So you can only see here a thin sliver of Kotlin in our main app. Back in April of 2016, almost all our code was not in libraries. It was just in that one monolith. We had over 100,000 lines of Java, 0 lines of Kotlin. And since then, we've removed almost 20,000 lines of Java from our main app and added 8,000 lines of Kotlin. So you can see there from the numbers that Kotlin is significantly more expressive. And again, a large legacy problem. But if you instead switch to those libraries that I was talking about earlier, you can see that we started in April of 2016 with about 8,000 lines of Java in our libraries. And this includes the forked version of Owly that we've not yet removed. So since then, we've added 34,000 lines of Kotlin in libraries. Most of the Kotlin code we've written has been in libraries, and most now of our library code is in Kotlin. You can see Java's sort of been up and down as we stopped writing new features in Java and started only removing it. So here again are the milestone events overlaid onto the chart. We have the founding of the Kotlin Guild, where we really started to accelerate our development in libraries. We have Kotlin 1.1 being released, which was peak Java. And we have the start of the Kotlin Book Club just after that, and Kotlin Official, where we again started to remove old Java code. So let's look then at the milestones of 2016. How did we get to where we are today? So this is a chart showing the number of libraries that we have, the number of which are mostly Java, the number of which are all Kotlin, mostly Kotlin, or partially Kotlin. So as I said, we started April of last year with 6 libraries and nothing Kotlin. Our very first data class, we checked in mid-April, and now we had 1 partially Kotlin library. Then in May of 2016, we went up to 9 libraries in total, but still only 2 partially Kotlin. So we were switching to library-driven development, but we hadn't yet really bought into Kotlin. In June now we're up to 11, but we've really started to try to take bits and pieces of each library, mostly data classes, and convert them. So now we have 5 libraries with Kotlin in them. Later in June of 2016, we created our first all Kotlin library. In July, we were up to 13 libraries, 2 of which were now fully Kotlin, Compose Feedback, and Query Builder I mentioned earlier. August was the first time we had Kotlin in half of our libraries, but unfortunately we went back down to a single all Kotlin because we had problems with Query Builder, Capt, and Dagger. And this caused us to remark, for all sad words of tongue and pen, the saddest are these. I had to convert Kotlin back to Java. But fortunately we resolved our issues, and soon we were back up to 2 all Kotlin libraries. And here's the commit where we brought it back in, finally removing apt. In early October, we added another all Kotlin library, and we were up to more than half our libraries having some Kotlin. We ended the year with 10 libraries out of 16 having some Kotlin. Not bad for 3/4 of the year. Now, how do we do this year? As I said, we ended 2016 with 16 libraries, 10 mostly Java, 6 mostly Kotlin. And earlier this year, at the 1.1 release, we had 18 libraries. In April, we finally crossed to having half of our libraries mostly Kotlin. We were really, like I said, bought in at this point. We were actively converting old Java code while making new Kotlin code. Then in June, 18 of our libraries were partially Kotlin. The only 2 holdouts are those forks of old legacy libraries that I mentioned earlier. In July of this year, we officially had half all Kotlin libraries, and things were moving at a rapid pace. And finally, the last check I did before we came here, we have 21 libraries, only 5 of which are mostly Java, 13 are all Kotlin, and 16 are mostly Kotlin. From 0 to 13 Kotlin libraries in about a year and a half. And if you normalize our library code, you can see that relative from 0 to 100%. In April of last year, we of course started 100% Java. And since then, we've actually moved to 70% Kotlin in our libraries. And it was actually around the 1.1 event, we crossed 50-50. So the final piece of the journey, Kotlin announced as an official language. Kotlin had been getting a lot of press all year. If you're like me, you were watching the live stream at work in this time zone. And the team at Hootsuite, we were really hopeful for an announcement about Kotlin. We had been, developing it all year. We had almost given up hope. But then we heard Stephanie Cuthbertson say, "We have never added a new programming language to Kotlin." And for a second, I was fearful. Were the Swift rumors true? Had Google gone Go on Android? No. Kotlin was officially production ready. And now if we review those risks that I spoke to previously, a non-official Kotlin or Android language was now official. That was obviously the biggest piece of the puzzle for us, for our stakeholders, our product managers, et cetera. But also for the increased build times, we found that breaking up our features into libraries and bringing them in as precompiled modules really lowered our build times from the monolith that we previously had. We were worried about stability with our CI pipeline, and over the last year, things have gotten so much better, and I don't think we've had any issues recently. For the IDE tooling support, it was never really a risk, was it? Because JetBrains makes Android Studio, JetBrains makes Kotlin. You're always going to get great tooling support. And for hiring considerations, actually people have seen our Kotlin blog post, and they want to work with Kotlin, so they applied specifically to Hootsuite because we publicly announced we were working with it. So in conclusion, what did we learn from our Kotlin adoption? Kotlin has been a boon to productivity. We used to feel like this guy flying a biplane, Red Baron maybe. Now we're in the space shuttle. Developer happiness has greatly increased. We all love Kotlin like I showed in those retros. We've shipped better code. Our NPEs have dropped off. We have better stability. And interoperability has really been the key to adoption. If Kotlin weren't interoperable like something like Scala, we'd be Don Quixote over there tilting at windmills trying to convert our entire production app. No, incremental addition was our key to adoption. Convert that one class, that one library, and grow from there. And library-driven development has really helped that workflow. Decomposition of our app into Kotlin libraries. So we have grown and spread Kotlin culture with the Kotlin Guild at our company, with the Kotlin Book Club, which we're actually going to open up to the Meetup group soon. And we founded that Meetup group to share with the community different Kotlin-run workshops, beginners' nights, etc. And these have really helped us grow that culture, to grow that excitement. And we have a really passionate team at Hootsuite of Kotlin developers. We've seen people looking up problems from Kotlin in action and just excited by having figured something out. So you can do these too in your community and your company, and I know you'll see the same benefit. Thank you. So I have some Owlies. Unfortunately, they're not wearing any fancy hats for anyone who'd like to ask a question. And if you don't want to ask a question, but you want to solve one of these short puzzles, I'll also give you an Owly. Yeah?
Does Peon overlap with what the Netflix presenter was talking about, where I think it was Nebula?
So the question was, does Peon overlap with a Netflix presentation, Nebula? I wasn't actually at that talk, but I would love to talk to the presenter about it. Oh, and I either give you one after or toss to, oh, sorry. Yes.
So did you wind up putting into production any bugs that was because of the refactoring you were doing to Kotlin? And if you did, how did you handle that throughout the organization?
We've certainly hit some bugs along the way. Some of it was our own lack of understanding maybe about the nuances of Kotlin versus Java early in the process. Maybe we could have mitigated those by looking at the like bytecode or looking at the way Kotlin was interacting with the JVM, because we did ship some minor bugs that we had to fix after they had gone to production, yes. But sorry, was there some other aspect to your question?
Well, how did the organization feel about that?
I mean, I don't think that we had significantly more bugs because of Kotlin than with Java. I think when we refactor or add new features, there have always been bugs that show up in our crash reporting tool, but I can't recall anyone that would say so significant that it caused heads to turn from our Kotlin adoption. And I can probably toss one that far. There we go. Yeah?
I know that the team is now more productive because of Kotlin, but in the beginning, how much would you say the productivity was affected while you went over the learning curve?
So one thing that I feel is early on, the tool that they have in Android Studio and IntelliJ to convert Java to Kotlin is fairly good at writing Java-style Kotlin. And that's kind of what we were doing early on. So other than the time it took to either work on the cones or read the book or attend the guild, I don't think we really noticed a decrease in productivity because we weren't really writing idiomatic Kotlin. We were kind of just learning the syntax, which took maybe a few days, but it was later on that we kind of built up our own knowledge base that I think the time it took to learn those kind of idiosyncrasies of Kotlin and features of Kotlin coincided with the increase in productivity. So I don't think we ever saw more than a few days worth of drop. And I won't toss it this far, but you can come grab it after. Here you go.
So I am curious about some of the specific or concrete pain points that you had seen when using Kotlin libraries in a Java environment. There have been several talks that have mentioned, like having to litter your code with a bunch of annotations, like JVM overloads or whatever. I'm wondering if you can, just elaborate on the most significant problems that you found.
So I think the most significant that we had to work with for a while was Dagger annotations, getting the generated code right, having the proper AAR be built and imported into our main app, and seeing all the Dagger generated code. That wasn't, say, like a bug we shipped to production, but it took us a while before we figured out the right combination of annotations, and that was back when we were on Dagger 1, so it was a little more finicky, say. Other than that, I know there have been small things like sometimes when you invoke Kotlin Lambda from Java, I guess you have to give it nothing or unit, because if you leave a Lambda, there's a default return, and it doesn't cause a compiler error, but it causes a bug. I know that happened a couple times before we realized exactly what happened. A lot of the stuff now, I think the biggest source of problems was capped, but since capped 3, it's a lot better. So those problems have pretty much been mitigated. Yeah.
How has Kotlin affected your choice of your percentage of functional programming versus Java functional programming?
Yeah, so sorry, I hadn't been repeating the questions. The question was, how has Kotlin affected our functional use of the functional paradigm over, I guess, like purely object-oriented?
Versus Java's version of functional programming, which is very stiff.
Versus Java's version of functional programming. So on Android, at least, we had, of course, we're stuck in kind of Java 6, Java 7, so we don't have lambdas. So on Android, Java is even less functional. But I think, and maybe it's because we had a number of Scala devs at Hootsuite who were working on Kotlin with us, that we kind of lean more toward maybe that style of functionality. We used RX Kotlin extensively for like asynchronicity. I'm not sure if that exactly answers your question.
I found that it's a lot easier to use it than the Javas because the collections are much nicer to use with functional.
Yeah, absolutely. So sorry, the comment was that the collections API is much nicer to use functionally in Kotlin, which absolutely I completely agree with. It's much more of a pleasure to develop that way. Oh yeah, I'll toss you your Owly. And then I've got the one left for. Here you are. And I don't have any Owlies left, but I have a couple more minutes to take any questions or if anybody's got an answer to the puzzle. Oh yeah, I guess wait for them.
How big is your guys' total team and then the individual teams you have working on different feature branches you were saying?
Yeah, so how big is our teams that are working on these features versus the core team? So the core team was at about 3 full-time developers, a manager, a QA, and then the other teams are approximately that size, of which there are 2 other embedded teams. And then some teams do a small amount of Android tickets here or there, say. Yeah.
Have you noticed any kind of performance difference, like a runtime performance difference after converting to Kotlin?
Nothing that I've personally noticed. It's something that has always been on my list of things to do, is really kind of get some good benchmarking of a feature that we've converted or a library that we've extracted. But unfortunately, I don't have any hard numbers, other than a perception that there is no difference. Perfect. Oh, one more question at the back.
So you mentioned when Android got official support that more teams jumped on board with working with Kotlin. Was there anything else that was kind of the reasons why they didn't start other than support? Were there other like pushback points?
I think it was, since before it was official, it was hesitance to bring it into the stack. So like I said, that team was fairly isolated. They worked on a specific subset of our libraries that were purely Java. And it was, yeah, I think it was just kind of hesitance at adopting something that wasn't official, wasn't entirely proven. Perfect. Is there any other question? Nope. Sorry, feel free to come up and chat with me after. Thanks so much for coming, everybody. I'm around to talk after if you'd like.